Hello, hi, good morning my dear students. Welcome to the chemistry class. So in the last class, before the last class we have started the new chapter, that is states of matter. In the last class we have started the laws of gases, that is 4 laws are there: Boyle's law, Charles law, Gauss-Lewis law and Avogadro's law. So yesterday we have studied about the Boyle's law. So today we will start the remaining 3 laws and we will complete that class. Okay, so let's begin the second one, that is Charles law. The Charles law, as I have said in the previous videos, that is here the 4 laws: Boyle's law, Charles law, Gauss-Lewis law and Avogadro's law. These laws are going to be expressed on the basis of 4 terms, that is pressure, volume, temperature and N. N means amount of substance. So here, based on these only 4 terms, we are going to define the laws, means these laws of gases. So I said the Boyle's law is going to have the relation only on the basis of pressure and volume. Can you see here? I have mentioned here that Boyle's law is going to give the relation between the pressure and volume. So it means that in the Boyle's law, it is have the constant terms are temperature and amount of substance. For that reason I said at constant temperature the gas of fixed amount of mass is having, in this the volume is inversely proportional to the pressure. So inversely proportional to the pressure means as volume increases, pressure decreases, or in other words, pressure increases, volume has to be decreased. So this is about the Boyle's law. The same thing today we are continuing the remaining. So let's see here. The Charles law is going to give the relations between volume and temperature. So before we move to the Charles law, you just have that visualization in your mind. So volume and temperature, how they depends, whether they are directly depends or inversely depend. So think that you are having a balloon. Last class only I said we are going to use the example balloon. Why? Because it is a familiar for us all, for that reason. So think that to increase the volume, how the volume will increase, whether at increasing the temperature or decreasing the temperature. Just to think that when the balloon is exposed to the hot, means sunlight, or to the heat, it's going to expand that, because the particles which are present in the gas, they are undergo faster movement. For that reason it's need a greater volume. For that reason it's going to increase the volume. If the volume is extended more, at that time the balloon is going to blast, isn't it? For that reason, as the temperature increases, volume also increases. This is our basic knowledge. We have to visualize that one. So for that reason, so here the relations volume is directly proportional to the temperature. Means in the Charles law we are going to express only the volume and temperature. It means that pressure and the amount of substance are constant. You have to remember this one. So very simple concept it is. Look here. Charles law states that at constant pressure and constant amount, means number of moles of the gases compound are constant. At constant pressure and constant amount of gases, the volume of the gas is directly proportional to its temperature. The volume of the gas is directly proportional to the temperature. So by replacing the proportional, we are keeping the constant, that is K into P. So it means that V divided by T is equal to P. So why we are writing like this means, why? Because if the initial volume is V1, then we can take the temperature as T1. If the volume is increased, at that time we can take V2 divided by T2. So it means that these two, V1 divided by T, is a constant. Similarly, V1 by T1 is equal to, it is also constant K. V2 by T2, it is also constant. So K are same. For that reason, we can call directly V1 by T1 is equal to V2 by T2. V2 by T2. So while doing the problem, we are going to use this kind of the formulas, and even we can change this one. So we can send this V2 to the left side. Therefore, it becomes V1 into T2, that is equal to V2 into T1. V2 into T1. So these are the 2 separate formulas extended by the laws of Charles. Charles law. So here you have to remember the 4 laws and you should be capable to write the mathematical expression. What is the mathematical expression? First you have to define Charles law. So Charles law states that at constant pressure and fixed amount of gas, volume of the gas is directly proportional to the temperature. This is called as Charles law. This is very much simple. And next one you want you have to do, you have to write the mathematical expression. That is V is directly proportional to the T, and below proportional is replaced by the is equal to and some constant K. V is equal to K into T. Sometimes if we want to have some extra formula, if you have written up to here, then it is fine, no problem. While writing the Charles law and the mathematical expression, up to here it is sufficient. But I wish that in the notes we just continue this one. So when we move this temperature to the left side, it is having into, so T becomes divided by V divided by T is equal to K. If volume and temperature, if we are taking for initial time, it is V1 and T1. After some time, if we are considering volume changes V1 into the V2 and temperature changes T1 into the T2. Therefore, these two are the constant for the present. V1 by T1 is equal to V2 by T2, and we can rearrange this expression in this components. I hope you can understand the Charles law. Is it clear for you? Charles law, Boyle's law, these are the important, and even the last one, Avogadro's law, is also important. Why means we will come to later. So here, can you see here in the Boyle's law and Charles law, we have taken the constant. What are the two terms we have taken constant things? One is amount of substance, another one is a pressure. So here, how is it possible to draw the graph? Draw the graph to show the Charles law. They may ask you for 1 mark. Draw the graph to show the Charles law. Can you see here? We are not supposed to take the pressure here. Why? Because it is going to give the relations of volume and temperature. Therefore, I will take the temperature here and I will take the pressure. So along x-axis is temperature, along y-axis pressure. Look here, we have taken the constant as temperature. Think that we are going to get the straight, means linear line is appearing. Why this is appearing in this way means you are familiar with the definitions. You know the volume and temperature, they are directly proportional to each other. Means they are increasing together and at the same time they are decreasing together. For that reason, we are going to get the linear graph. That is, pressure is directly proportional to, sorry, we are not supposed to take the pressure, we have to take the volume. So volume is directly proportional to the temperature. As the volume increases, temperature also increases, isn't it? So let me draw another graph. What it means here? Can you see here? So don't say that I am not drawing more than 2. So you just imagine that I have drawn one graph. So in this graph is going to represent that the volume, how it varies with the temperature. Same thing here. Can you see here? As the volume, you can take any of them. First one I have taken here. As volume is V1, the temperature is T1. If I have taken volume as T2, can you see here? I have increased the volume. So it means the temperature is also increasing. So it means that both are directly proportional. They are simultaneously increase and simultaneously decreases. Why I have drawn this more than one straight line? Why? Because here the constant one is amount of substance, another one is pressure. So I would like to say this is P1, P2, P3 and P4. So we are not actually have any changes in the pressure. Why? Because we have to carry this expression only in the constant pressure. Think that this is the experiment conducted at the pressure P1. This pressure will be remains as a P1 in the whole reaction, whole experiment. Similarly, the same experiment, if it is conducted for the different pressure, means pressure will be remain same, but we are taking different pressure. That is P2, P3, and this is P4. At the pressure P4, the reaction is carried out in this graph. Are you getting this one? This is the reaction carried. So my question is whether P1 is greater or P4 is greater. Think here. Volume is here. Can you see here? If I draw some graph, the volume here, volume is greater. As the volume is increases, whether pressure decreases or increases, you have to answer for this question, because in the last Boyle's law we have discussed it. So what does that means? At the larger volume, the pressure remains smaller as the larger volume, pressure remains smaller. So if we want to apply the pressure, means we have to reduce the volume, isn't it? For that reason, here, as the volume increases, volume is increasing here. As the volume increasing means pressure has to be decreased. For that reason, here P4 is at lesser value. Can you see here? It is having smaller volume and this one is having the greater volume. For that reason, P4 is greater than P3 is greater than P2 and P1 is very much smaller. Why? Because P1 is having the greater volume. It means that P1 is smaller than the P4. For that reason, so no, don't worry, they are not going to ask such questions, but you should know this meaning. So here in this graph, P1, P2, P3, P4 are the constant pressure, whereas this P1 is having the greater volume. It means that how they are varying means they are inversely varies. For that reason, if the volume is greater, means pressure should be smaller. If the pressure is smaller, means it means volume should be lesser one. So it means that, can you see here? We are not having actually greater and smaller pressure here. We are not able to recognize this one. We can say that here the volume is greater. Can you say volume is greater means pressure should be smaller. Here volume is smaller compared to this P1. If the volume is smaller means it means pressure should be greater. For that reason, I have written as P1 is having the smaller pressure than that of P4. Are you getting my point? What you have to remember here is you should be capable to draw the graph. This is called as Charles law. Charles law is going to express the relation between volume versus temperature. So this is the relations. Are you getting my point? So volume versus temperature. In this graph, we are going to get the straight line. Why? Because these two are increasing simultaneously. No need of expression, but you have to remember this one. Here the pressure remains constant. In the Boyle's law, temperature was the constant. For that reason, we have called that as a isothermal. Isothermal means the temperature remains same. So whereas here the pressure remains same. Here the pressure remains same. For that reason, we have to call that as same is nothing but iso. Iso bar we have to call BAR. Iso bar graph. What is this iso bar? Iso means same. BAR, bar is nothing but it is the SI unit of pressure. SI unit of pressure. You have to remember the one condition. Here pressure can be expressed by the SI unit. Means we are not calling that as bar is the SI unit of pressure. But pressure can be expressed in different units. That is, one is bar, BAR, bar. Another one is Pascal, capital P and small a, Pascal. Another one is actually we are having term that is TOR, top. So whenever you move for the next classes, further classes, or even in the second PUC, you are going to have a familiar about these SI units. These are not all SI units. Commonly we are calling the SI unit of the pressure as bar. And some in the problems we are using the Pascal also. PA is the unit Pascal. Torr, TOR, only in very few problems, particularly in second PUC, you are going to study this torr SI unit. Therefore, torr is one of the SI unit, Pascal, and another one is bar. So here isobar is nothing but bar indicates that pressure is same. Therefore, at constant pressure, we are drawing this graph. This is how the relations explained by Charles law. So is it clear for you? So we will move the next one. I hope based on this relations only you can able to define. It's going to be the relation between volume and temperature. So next one is third one, that is Guy-Lussac's law. Guy-Lussac's law. So where he is going to explain that the relation between pressure and temperature. Pressure and temperature. So here, if it is going to relate the pressure and temperature, then we have to take the constant as volume and amount of substance. Volume and amount of substance. So here at Guy-Lussac's law, volume and fixed amount of gas is same. Means volume is not changing and even the number of moles of gases are fixed. So then what we have to change is we have to change the pressure and temperature. So before I explain you the statement of Guy-Lussac's law, first you have to realize that how this pressure varies with the temperature. So if the temperature varies means, if temperature we increase it means whether pressure increases or decreases. This is the question. So just you imagine, or you can give the example, or you can realize in your surrounding areas. As the temperature increases, means that we are increasing the temperature, pressure increases or not. In the last example I said that same thing, balloon is containing the gas. If we increase the heat, means in the balloon we are applying some heat to that compound. What happens means the volume is remains same only. Why? Because we are taken the volume as a constant, and number of particles also remains same. Think that it is having this much of volume. So in this volume of the gas, it is containing some gases. If I heated means, if I begin to heat means, the particles which are present in that, it will begins to move, means the particles will be disturbed and it will move randomly. So if they are staying simply freely without any disturbance means they are not having any pressure. If we increase the temperature, it means that they are going to run randomly. If they are running randomly means it means that they are under the pressure. The pressure will be increases. It means that as the temperature increases, pressure also increases. As the temperature increases, pressure also increases. Ultimately, as the temperature decreases, pressure has to be reduced. So it means that pressure and temperature, they are directly proportional to each other. Are you getting my point? How we are writing? But don't worry, you are not supposed to add these terms. You have to only remember the terms. What the law is going to relate, whether pressure, temperature, or on what terms they are going to relate. Based on that, you can able to define this class. So Guy-Lussac's law is going to express the relations between pressure and temperature. Pressure and temperature. So let me take my example. Pressure is directly proportional to temperature. Why? Because as the temperature increases, pressure also increases. So what you have to define is Guy-Lussac's law states that at constant volume and fixed amount of gas, the pressure of the gas is directly proportional to the temperature. So here same thing as we did in the previous P. It is a proportion. We have to keep that as constant, that is small k, and T as it is. The same thing as we expressed for the previous charge law, we can say P divided by T is equal to K. Suppose initial time P1 and T1, the K remains same, and same thing. So it means that P1 divided by T1, the constant remains same. The same again, if the pressure changes P2 upon T2, the constant will be same. So replacing K, we are going to get the formula P1 by T1 is equal to P2 by T2. Are you getting? If we want, we can change that formula. P1 into P2 is equal to P2 into T1. Are you getting my point? So these are the expression. According to me, up to here it is sufficient for you. Soon after writing the Guy-Lussac's law, you have to write the mathematical expression. And one more thing you have to remember, this is the most important activity. For every expression, if you are written up to here, there is no problem, it's good, fine. But soon after writing this formula, you have to write what is P. So P is the pressure, K is the temperature, K is the constant, T is the temperature. You have to express the meaning of those terms. Okay. So coming to the graph. So here all the graphs are not necessarily not important, but only for our understanding we have to draw them. That's all. I hope you remember this one, Guy-Lussac's law. Lussac's law, you can call that as Lussac law, however you want. So main thing is going to express only about the pressure and temperature. So coming to the graph, here what we have to take the constant. Constant is volume and amount of substance. Means volume we have to take the constant. So volume we have to take the constant, means remaining is pressure and temperature. So I will take pressure here, pressure along the y-axis, temperature along the x-axis. Are you getting this one? So here, how they are very, means they are undergo directly proportional. Means they are undergo increasing together and decreasing together. For that reason, I would like to draw a graph again the straight line. Why? Because they are undergo directly proportional. Same thing as I did here. In the previous, the volume, pressure was the constant. For that reason, I have taken P1, P2, P3 as a 4 different straight line. Similarly, I would like to call here pressure and temperature, they are varying by the constant value. Constant value. Think that I am taking as a V1 here. So I would like to extend another graph. Means at a constant value V1, the graph is appearing this way. If I change the volume change means it's appearing the graph as V2 in this way. At V3, graph is appearing in this. Similarly at V4. So let me tell you whether V1 is greater or V2, V3 and V4. Which one is having the greater? You have to recognize me and you have to tell the answer for this one on the basis of whether as the pressure increases, can you see the pressure is having, V1 is having the greater pressure is greater and V1 is having the smaller one or greater one. So I don't know actually, but you have to answer for that one. So take it as a homework, don't write in the work, but soon after finishing this example, you have to answer to this question. Let's see, very few of your friends in the last few days guys asked such question, that is in the periodic classification. Only hardly 5 to 10 students have replied. So let's see. So whether V1 is greater or V4 is greater. So you have to explain and you have to justify your answer. Why you are saying V1 is greater and why you are saying V4 is greater. Why? Because I have already explained this one. So let's have a conclusion by your own words. So this is the graph which explains about the Gauss law, pressure versus temperature graph, and volume remains same. Here the volume is constant. For that reason, here we are going to say this graph, we are saying that as iso. Iso bar means pressure is constant, that is Charles law. Isothermal means Boyle's law, because temperature is constant. Thermal means temperature, isothermal. Here the gas is Luzak's law, the volume is constant. For that reason, we have to call isochore. C-H-O-R-E. Isochore. Iso means same. Core is nothing but it is not a SI, but we are saying volume in the form of core. But we are not used any of this core word in the future. This is the first and it will be the last. But you have to remember, wherever we are writing the isochore, it means that iso is nothing but constant. Which one is constant? The volume remains constant. For that reason, we are calling that as isochore. Isochore is nothing but the graph which is having the constant value, that is called as isochore. Isochore graph appears only in the Gauss sequence. Isobar appears in Charles law. Isothermal appears in Boyle's law. Is it clear? So this is isochore. So soon you have to write the comments in video only. Below you can have that comment. So let me know how many of you know whether V1 is greater or V4 is greater. Give your answer below that video only. Don't send in a WhatsApp. So let's begin how you are having interaction among yourself. Okay. So next one is last one, that is Avogadro law. So Avogadro law is going to explain that. So in the Avogadro law, we are defining the terms, that is same. Which one we have to take the constant? I have drawn some points there. So Avogadro's law is going to express the relation only two terms. That is volume and amount of substance. So here volume and amount of substance, Avogadro law is going to express the relation between volume and amount of substance. I don't know whether it is directly proportional or inversely. We will come to know that. So here volume and amount of substance, then remaining is pressure and temperature. These two are, I have to take the constant. Very simple and easy. It seems to be like a game to interact with the pressure, volume, temperature and amount of substance. So don't worry, don't be tension so that you understand these laws, because these are not a larger one. So these are easiest compared to your first chapter. So how we have to define this one? Avogadro's law states that, actually we are not supposed to say in this way, but simply I am telling you. Avogadro's law states that at constant pressure and constant temperature, volume is directly proportional to the amount of or number of moles of gas. The volume is directly proportional to the amount of or number of moles of gas. Actually, how we are defining this statement means Avogadro's law states that at constant pressure and constant temperature, the same volume of the gas is containing same number of gaseous compound. Means if the volume is same, the number of particles of same gaseous compound remains same. It means that at constant temperature, pressure and volume has to be remain constant. At that time, the number of gaseous molecules is equal to same content. For that reason, we are going to say that you can define in the two way for this one. If you feel this is in the easy way, according to me way, because we have defined the remaining laws in the same way. For that reason, you can write the same thing. So in the textbook, you can have the different statement, but you can write in this way also. So Avogadro's law states that at constant pressure and constant temperature, the volume of the gas is directly proportional to the amount of substance of gas, number of moles of amount of substance of gas. Means V is directly proportional to the N. At constant pressure and temperature. For that reason, so I may call it V is equal to K into N. For your kind information, here we are not having to draw a graph for this expression, because here number of moles are actually not increases. Keep in your mind, as the volume increases, number of molecules are not going to increase. Keep in your mind. If we said means it's a wrong expression. Why? Because volume increases, number of moles are never going to increase. If volume decreases means the number of molecules are never going to decrease. But how we are defining this one means we are taking the pressure and temperature as a constant. We have to keep this as a constant. Simultaneously, according to the pressure and temperature, we have to take volume also constant. We have to keep the volume also constant. Means when volume is V1, means take that the volume is constant and given pressure and temperature. At that time, how much of number of moles N are there? The same N remains. When we again keep this pressure, temperature, volume as a constant in the further experiment. So it means that at constant pressure, temperature and volume, the number of gases remains same. Similarly, that we can say that the same volume, temperature and pressure in this condition, again whenever we observe the same compound, it will remains the N value will be same. So it means I ಏನು ಹೇಳಕ್ಕೆ ಹೊರಟಿದ್ದೇನೆ ಅಂತಂದ್ರೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ಬಿಟ್ರಿ ಬಹಳ. Think that it is a container. This container containing you can take the gaseous molecule, hydrogen is there. I have taken 1 liter of compounds. This is the volume, 1 liter, or we can take anything. The volume is 1 liter, and pressure and temperature are constant. Temperature is constant. So constant is nothing but we are taking the standard constant value, STP, standard temperature and pressure. Standard temperature pressure is nothing but what? Standard means fixed temperature and pressure. Fixed means how much fixed? Standard temperature pressure is means that we have to take the temperature as 0 degrees Celsius. That 0 degrees Celsius is nothing but according to the Kelvin 273 Kelvin is called as standard temperature. Even pressure we have to call that actually 1 bar pressure. I said the pressure are having the 3 assignments. So among those, one is the bar, another one is the Pascal. We are going to use only 2 terms here. If the pressure is 1 bar, 1 bar is nothing but 10 raised to 5 Pascal here, capital P and small a. 1 bar is nothing but it is equivalent to the 10 raised to 5 Pascal. So it means that when the temperature is exactly 0 degrees Celsius and pressure is 1 bar, or if the temperature is 273 Kelvin and pressure is 10 raised to 5 Pascal, this kind of temperature and pressure are called as standard temperature pressure. Commonly we are calling that as STP. STP is nothing but it is a short form of standard temperature pressure. You have to remember in your mind that STP matlab standard temperature and pressure. So whenever we are saying at standard temperature pressure, you have to remind the word in this condition temperature and pressure remains 0 degree Celsius and 1 bar, or in other word 273 Kelvin and 10 raised to 5 Pascal. So only at this temperature and pressure we are calling this as a standard temperature pressure and water. So ಈ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗಷ್ಟ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ಅಂಡ್ ವಾಲ್ಯೂಮ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರಿಮೈನ್ ಸೇಮ್. ವಾಲ್ಯೂಮ್ 1 ಲೀಟರ್ ಅಂತಂದ್ರೆ ಇದ ಸೇಮ್ ಥಿಂಗ್ ದಟ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಸಿಂಪಲ್ ಆ್ಯಂಡ್ ಟೆಲಿಂಗ್ 10 moles of N, 10 moles of hydrogens are there, 10 moles of hydrogens are there. With the same conditions, 1 liter of volume and the temperature and pressure remain same. Again, we may call the number of moles of the gases should have the 10 mole only. Why? Because we have maintained the volume as the same and we have maintained the temperature and pressure as the same. At that condition, the number of hydrogen should be equal to the 10 moles only. This is what the condition. So here we can't say the word as the volume increases, N never increases, or in other word, volume decrease only say nitrogen. N, the amount of substance also never decreasing. It means that volume and amount of substance, these are directly proportional. It never means that volume increase ಆದಾಗ amount of substance ಯಾವತ್ತೂ increase ಆಗಲ್ಲ. ಯಾಕಂದ್ರೆ amount of substance ಯಾವಾಗಿದ್ರೂ ಸೇಮ್ ಇರ್ತದೆ. amount of substance ಅಂದ್ರೆ ಏನು ಅಂತಂದ್ರೆ ಈಗ 5 kg ಶುಗರ್ ಇದ್ರೆ ದಟ್ 5 kg ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ ತಕ್ಷಣ 5 kg ಇದ್ದರೆ 10 kg ಹೆಂಗಾಗುತ್ತೆ? ಹೈಲಿ ಇಂಪಾಸಿಬಲ್ ಇಟ್ ಈಸ್. ವಾಲ್ಯೂಮ್ ರೆಡ್ಯೂಸ್ ಮಾಡಿದ ತಕ್ಷಣ 5 kg ಇರುವಂಥ ಶುಗರ್ ಹೌ ಕ್ಯಾನ್ ಇಟ್ ರೆಡ್ಯೂಸ್ ಟು ದ 4 kg? ನೆವರ್, ಇಟ್ ಇಸ್ ಹೈಲಿ ಇಂಪಾಸಿಬಲ್. ಸೇಮ್ ಗ್ಯಾಸಸ್ ಕಂಪೌಂಡು ಈಗ 10 ಮೋಲ್ ಇರುವಂಥ ಹೈಡ್ರೋಜನ್ಸ್ 2 moles ಹೆಂಗೆ ಆಗ ಸಾಧ್ಯ? ಅಥವಾ 10 moles ಇದ್ದಿದ್ದು 20 moles ಆಗೋದಕ್ಕೆ ಹೆಂಗೆ ಸಾಧ್ಯ? ಹೈಲಿ ಇಂಪಾಸಿಬಲ್. ಇಟ್ ಮೀನ್ಸ್ ದ ಜನ್ರೇಷನ್ ಅದ ಒಂಥರ ಏನದ ರಿಸರ್ಚ್ ಅಲ್ಲ, ಒಂಥರ ಏನೋ ಚೇಂಜಸ್ ಆಗಿಬಿಡ್ತಾ ಇದೆ. ಇಟ್ಸ್ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ಇಟ್ ಇಸ್ ಎಕ್ಸೆಪ್ಷನಲ್ ಟು ದ ಸೈಂಟಿಸ್ಟ್ ಆಗಿಬಿಡ್ತಾರೆ. ಅಂದರೆ ಸೈನ್ಸ್ ಮಿತಿಮೀರಿದಂಗಾಗುತ್ತೆ. ಸೊ ಹಂಗಾಗಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಸೊ ನಾನು ಏನು ಹೇಳ್ತಿದ್ದೇನೆ ಅಂತಂದರೆ ನಾಟ್ ಓನ್ಲಿ ದ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಆ್ಯಂಡ್ ಟೆಂಪರೇಚರ್, ಇವನ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ವಾಲ್ಯೂಮ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟೆಂಟ್. ಈ ಮೂರು ಕಾನ್ಸ್ಟೆಂಟ್ ತೊಗೊಂಡಾಗ ಅಷ್ಟ ಮಾತ್ರ ಏನು ಇರ್ತೈತಿ? ಎನ್ ರಿಮೈನ್ಸ್ ಸೇಮ್. ಎನ್ ಎಷ್ಟು ಇರ್ತಿತ್ತು ಅಷ್ಟು ಇರ್ತೈತಿ ಅಂತ ಅರ್ಥ. ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳತ್ತೀವಿ ಅಂತಂದರೆ, so in this statement we have to say that at constant pressure and temperature at a constant volume the number of moles of gases remains same. ಎಲ್ಲೇ ಹೋಗ್ರಿ ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಇತ್ತಂತಂದ್ರೆ ಎಷ್ಟು ಗ್ಯಾಸಸ್ ಇರ್ತಾವೆ ಅಷ್ಟೇ ಇರ್ತಾವೆ. ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ, ಫೈನಲ್ ಇದು ಹೇಳಿ ಕಾನ್ಸೆಪ್ಟನ್ನು ಮುಗಿಸ್ಬಿಡ್ತೀನಿ. ಏನಂತಂದರೆ ಹಾಗೆ ಅನ್ಕೋರಿಪ್ಪ, ಯಾವುದು ಹೈಡ್ರೋಜನ್ಸ್ ಅದಾವೆ, 10 mole ಹೈಡ್ರೋಜನ್ಸ್ ಬೇಕಂತಂದರೆ ನಮ್ಗೆ ಏನು ಕಂಡೀಷನ್ಸ್? ಟೆಂಪರೇಚರ್ 0 ಇರಬೇಕು, ಪ್ರೆಷರ್ 1 bar ಆ್ಯಂಡ್ ವಾಲ್ಯೂಮ್ ಶುಡ್ ಬಿ 1 liter. ಇಷ್ಟೇ. ಏನದ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅದು ಎಷ್ಟಾಗುತ್ತೆ? 1 mole, 10 moles ಅದಾವೆ. If I would like to conduct this experiment in the another separate place, and that condition also I am applying the same conditions, means temperature I am taking 0 degree, pressure 1 bar and volume is 1 liter. ಬೇರೆ ಯಾವುದೇ ಗ್ಯಾಸ್ ಐತೆ ಅನ್ಕೋರಿ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ಹೈಡ್ರೋಜನ್. ಕ್ಲೋರಿನ್ ಇದ್ರೂ ಸದ್ಯಕ್ಕೆ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ದ 10 mole only. ವೈ? ಬಿಕಾಸ್ ವಿ ಆರ್ ಅಪ್ಲೈಂಗ್ ದ ಸೇಮ್ ಕಂಡೀಷನ್. ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಅದ. ವಾಲ್ಯೂಮ್ ಸೇಮ್ ಅಂತ ಗ್ಯಾಸಸ್ ಎಕ್ಸ್ಟ್ರಾ ಹಾಕಕ್ಕೆ ಬರಲ್ಲ, ಕಡಿಮೆ ಹಾಕಕ್ಕೂ ಬರಲ್ಲ. ಇಟ್ ಮೀನ್ಸ್ ವಾಲ್ಯೂಮ್ ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇದ್ದಾಗ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಗ್ಯಾಸಸ್ ಏನಿರ್ತಾವೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತೈತಿ, ಸೇಮ್ ಅಷ್ಟೇ ಇರ್ತೈತಿ ಅನ್ನೋದನ್ನು ಮಾತ್ರ ನಾವು ಹೇಳಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಸೇ ದಟ್ at constant pressure, temperature and even volume has to be same, constant only. At that condition number of gases molecules remains same. Keep in your mind, as we have explained here in the previous, this Avogadro's law is not varies in that way. Okay, so we will see this expression Boyle's law, Charles' law, Guy's law and Avogadro's law in detail one by one in the next class in a short video. Okay, so let's see the continuity in the next classes. So until if you are having any doubt, just call me and text me. Have a nice day.